For everyone, whether you're an amateur nerd like me or a professional geek like the professor here, here's a taste of what we've got coming up.
Over the next 3 nights, we're going to witness some of the most remarkable sights in space. One of which will be the colour of Dara's face when he's strapped to a table and tilted upside down to learn what it's like to be an astronaut.
It's weird, it's like having chubby cheeks, like I've stored nuts away for the winter.
At least it was warm where I was, unlike Glastonbury Tour, where Brian heads to explain how scientists can work out where the Earth is in space at any given time.
And from our headquarters here at Jodrell Bank, each day we'll witness a unique astronomical event, starting off tonight with a rare sighting of Jupiter in the same part of the sky as its planetary neighbour Uranus.
Then tomorrow we'll see a partial solar eclipse.
And on the third night, I'll give you top tips on how to observe a meteor shower. Well, this is January in Macclesfield and it is freezing. Strangely, it's a point in the Earth's orbit called perihelion, which is the closest point that the Earth approaches the Sun. But it doesn't feel like it. We are at the mercy of the weather here. But another member of our team, Liz Bonin, is halfway around the world in somewhat sunnier climes. Liz, how are you?
Thank you very much, Brian. Welcome to beautiful, sunny Hawaii. I don't mean to rub it in, but it is absolutely glorious here this morning. But you might be wondering what I am doing in the mid-Pacific sunshine when this is a program about the night skies. Well, I'm going to show you how Earth has a direct physical connection to our solar system and beyond, and how the planets affect us 24 hours a day, not just when the stars come out. And I'm also going to show you how we can learn an awful lot about our solar system right here on Earth, which is why I'm standing on the edge of this caldera or crater of the most active volcano in the world. This is called Kilauea, and it is certainly a sight for sore eyes. I'll be telling you a whole lot more about that a little bit later on.
Okay, now the first bit of stargazing we're going to do can take place over there with the big dish behind us because it's too bright. I'm here with Mark Thompson, the One Show astronomer. There's too much light there, isn't there?
Far too much light. We're using an optical telescope today, so light will ruin what we're trying to see. So we've got all the lights turned off, and we're using special low light cameras so we can see the sky.
Now we've had one thing that's worked out very, very well for us, which is even though we've had a cloud for the last while, the cloud seems to have disappeared. I'm looking at Orion over there, which you can always tell by the 3 dots for the belt we have. The plough is over there. What's the first thing, however? What is the first step?
Well, we've got a fantastic sky with constellations all over the place, but I want to draw your attention to the south and to that bright star up in the sky there. Can you recognise that at all?
I can't. It's a bright star. You're telling me. But
I'm telling you, it's
caught out before.
I'm telling you, it's a star. It's actually Jupiter, a planet.
So the first thing we can actually look at is a planet. Is
really,
one of, something really recognisable, really obvious, and really easy to find.
Easy to find. I've got the telescope lined up.
Okay.
Have a look, see what you can see.
Okay. Now.
How long is Jupiter going to be up there in the sky in that kind of position?
Well, it's going to be up there up until about March. It's going to disappear, and then it's only visible during the
I'm sorry,
daylight.
that is incredible. That is, I know it sounds corny because it's Jupiter, I've seen, but that is properly clear. You can see the different swirls of the weather. You can actually see the moons as well.
Can you see the shadow of Io on the disk of Jupiter?
I can't really. Is that a shadow of one of the moons?
Go on.
Really? Go on. Look at that.
I think years ago now.
That's exciting.
God, it's so amazing how quickly it reverted to an 8-year-old.
It is. And Jupiter
No,
itself.
you can see the bands. I've looked at planets before in telescopes, not often a telescope this good, but they always look like a kid's drawn them in the sky, don't they? They look like
and they look incredible. I think
drawing.
you're right. The beautiful thing about planets is that they're so easy to, generally, something like Jupiter, it's so easy to find. That's why we call it the amateur planet. It's really easy. It's a bright star, but it's Jupiter,
That is
and anyone can see it.
That is
Utterly.
absolutely lovely.
Even with
beautiful.
basic telescopes, you get that kind of view.
Yeah.
It's great.
Well, that's what Jupiter looks like in a telescope like this. What does it look like a little bit closer up? Jupiter is the solar system's largest and most massive planet. A huge gas giant with a diameter of 88,000 miles. It's so big you could fit Earth inside it over 1,000 times. Jupiter is more than 5 times further away from the Sun than Earth. It's so far away from our star that it takes 12 Earth years to complete a single orbit. But Jupiter spins much quicker than our own planet. Whilst the Earth takes 24 hours or a day to complete one rotation on its axis, on Jupiter it takes just 9 hours and 56 minutes. The planet is a giant ball of gas and liquid that has no solid surface. In its thick, churning atmosphere, gigantic storms have raged for centuries. The biggest of them all is the Great Red Spot. It's so enormous, it's visible even with small telescopes on Earth. This giant anticyclone was first spotted over 340 years ago and is large enough to swallow Earth 3 times over. Jupiter is orbited by 63 moons, and the largest 4 are particularly fascinating. Io is the innermost of the large moons and is the most volcanically active body in the solar system. Constant eruptions over thousands of years have scarred its surface and given it a sulphurous yellowy orange appearance. By contrast, Europa has a smooth but cracked icy surface. Underneath the ice is thought to be a salty ocean that could potentially harbour life. Next in line is the giant moon of Ganymede, an entity so big it would dwarf the planet Mercury. Its diverse terrain consists of ice and rocky material and is similar to that of its nearest neighbour Callisto, the outermost large moon. Callisto is thought to have the oldest surface in the solar system and bears the scars of 4 billion years of impacts. Jupiter is so colossal that despite being over 370 million miles away, it's still visible from Earth with the naked eye, and it's a sight that never fails to take the breath away.
That's quite an incredible start. And I'm almost don't feel the cold because the one dot in the sky turns out to be Jupiter. The first most obvious thing you can see turns out to be Jupiter.
It's utterly beautiful.
Isn't it?
Every
Isn't it
time I
stunning?
look at it.
Absolutely gorgeous. Now this also is quite lovely in its own way. This is the Lovell telescope, and this is an iconic place in astronomy.
You know, I mean, this thing was built about 3 months before the space age began. So it was the first telescope to track Sputnik. So Sputnik was seen going overhead. And someone told me earlier that there was a Russian probe that landed on the moon in 1964 and took a top secret image of the surface of the moon and beamed it back to Moscow. They intercepted it here and someone printed it out on the fax machine plugged into that console there.
That's incredible. It's beautiful. Now, we won't be using that to look at Jupiter, though.
No.
All right?
The Lovell's a radio telescope, so it detects light, just like an optical telescope, but it's light with a longer wavelength, so it's microwaves radio waves. So you see images of the sky,
But it won't look like the Jupiter that
you wouldn't recognise it.
as a child.
But I've got two beautiful images over here of Jupiter that were taken quite recently, actually, a couple of years ago. It'd be great if they would
Now,
come
where are
up
these
on
coming
the
from?
plasma screen. There it is. So these are from the Hubble Space
Oh,
Telescope.
really? From the
So
Space
we've got
Telescope?
links to the Hubble Space Telescope in orbit around the Earth. This is an image that was taken 2 summers ago, so in summer 2009, and it's Jupiter pretty much as we saw it through that telescope. But this is an image of Jupiter taken by the Hubble again, but a year later, so in summer last year. And you see that they're quite radically different.
Yeah, I mean, there's a band there which just, has it gone? Has it disappeared? Has it dissipated?
So this is a storm band on Jupiter. It's been there probably since Galileo looked at it back in the 17th century. But last year it vanished, and what's thought has happened is that a storm has thrown up ammonia crystals into the atmosphere of Jupiter, and that's obscured that red band. And it's actually, as we speak now, beginning to fade back again, so that storm is abating.
So this notion that they're somehow unchanging, eternal, set in the sky, this is rubbish. They're dynamic and they're always shifting.
They're dynamic objects. I mean, Jupiter's got some of the most dynamic weather in the solar system. We've also got links to some of the big telescopes around the world. We're going to be looking at them over the next few days. We've got a telescope in Chile, one of the European telescopes up in the Atacama Desert, and they sent us this picture actually yesterday of the Lagoon Nebula. Now this is
a nebula. What is nebula? It's a cloud of dust, is it?
It's a cloud of dust and gas. This is 4,500 light years away, and it's a star-forming region. So the bright blue stars you see in this picture are young stars, just at the start of their life, that are forming from the collapse, the gravitational collapse of the gas and dust in this beautiful nebula. And we've got a picture here from the Forks telescope, Forks North in Hawaii. You said that the heavens were dynamic and changing. This is called the Antenna Galaxy. It's a picture of the collision of 2 galaxies.
Wow.
So you're looking at hundreds of billions of stars there colliding together, and new stars form in that collision. So, and that's going to happen to us. The Andromeda Galaxy, 1 trillion stars, is going to hit the Milky Way.
But it's not going to happen just live in the next 3 nights.
Next week.
Next week. We want you to let us know what you can see in the night sky where you live. So if you could send us a picture, we'll show some of the best. Details of how to send them are on our website, bbc.co.uk/stargazing. If you're not sure how to take a picture of the sky, which is that basically, but there are also tricks and tips. Don't worry, help is at hand.
Yes, later on I'll be telling you what equipment you need and what you need to do to take those photographs. Plus, there are hundreds of stargazing live events running up and down the country throughout the course of January, which are aimed at beginners and people of all levels. Check the website for details.
Now, one small aim I have as well, and I'd like you to help in this, is to put Brian to the test. Now, he appears to know everything, but there are weaknesses there. So I'm going to put him through his paces later on. If you've got any question, no matter how stupid you might think it is...
No, it's not any question.
Well, as long as it's about the stars and space.
My mother-in-law love me?
Your mother-in-law shouldn't love you. That would be inappropriate and wrong. So, perhaps you've always wondered why planets don't crash into each other, what happens to a star when it stops shining.
Did I mean mother-in-law? Did I mean wife? I don't know.
Yeah,
anyway.
I don't know. Anyway, listen, not personal questions. It's not that kind of thing, right? Not recipe ideas. Not just about stars, right? Just let's not force the man into anything too embarrassing, right? Send your questions to stargazing@bbc.co.uk or ask them on Talk Stargazing, our live blog. Details are on the website.
Now, the fantastic thing about astronomy is that you don't really have to break the bank to get involved. Unfortunately, that message doesn't seem to have got through to absolutely everyone, as Mark found out.
So have you got an interest in astronomy then?
I do have a genuine interest in astronomy. I've got books on it. I've got several telescopes, never really got them working.
You've got several telescopes.
Many telescopes.
How many have you got?
At least 3 quite big ones.
3?
They're either broken or I'm stupid. Even the moon, sometimes I see it for a second, but then I've gone past it and I run out of energy. I'm too old to do this sort of thing on my own.
It's shocking, isn't it? Oh my God, and this is it.
This is my telescope.
This is your pride and joy. How much did it cost?
Well, I don't know, because my wife bought it for me as a birthday present, but not realising I was too lazy or stupid to actually commit to making it work.
So, you've never used it?
I have used this. It's got a device on to
Why have you not used that part?
because it's difficult.
It's too hard, is it?
It's quite hard.
Oh.
I like to be able to do... I don't want to read a book on it. I want to get out of the
Really
box
needs
and do
instruction,
it,
didn't
and
need
it's not designed properly to work like that.
You've got 3 of these,
Yes, sir.
and with a bit of practice and a bit of knowledge, you're going to see some incredible sights. But
I knew there'd be a but.
you need to kind of go back to the beginning and start off on the easier stuff first.
So the binoculars?
And possibly even the eye.
I've done that.
Let's get outside.
So we just use
Come
the
on.
naked eye.
Outside.
What's the point of having you if you're just gonna... I could do that on my own.
It's dark
And
our
cold.
eyes and we now appear in black and white.
Wow. Why
And
is
that's so our eyes can adapt to the dark. We've turned all the lights off, and this is a special low light camera that we're now using, so we can see stuff. Now, can you recognise anything in the sky tonight?
I see stars.
Yes. Can I draw your attention to the left, just up there? Can you see that bright star?
Gallifrey.
Gallifrey, not quite, very close.
Is that an actual... That's just a star, though, isn't it?
Gallifrey doesn't exist, I'm afraid
You
to
say that. We just
I'm
don't have
afraid to
telescopes
say
powerful enough to see
Maybe
that far.
that's what it is. That is Jupiter,
No way.
the largest planet in the solar system,
I wouldn't have known that was a planet. I would have just thought that was a star and I would have walked on by.
and ignored it.
Yeah.
What I'm going to do though is I'm going to show you Jupiter through a telescope.
This is what
Ooh, it's what you came here for. Now, if I can get you to hold this genuine astronomer's torch,
Because it
so-
belongs to you.
because it belongs to me. Now, this isn't like your swizzy, all singing, all dancing electronic telescope, but it's an ideal telescope for beginners. Something
Get
like this
wrong.
sets you up back £100.
Wow, bargain.
So it's bigger than yours. It's an 8-inch reflecting telescope. Got a mirror down the end there, which is the thing that collects all the light from the stars and objects you want to look at. And it's mounted on this Dobsonian telescope mount, which makes it really easy to move around the sky. It just twists left and right and up and down, and it's as simple as that.
Couldn't be easy.
So, shall we have a look at Jupiter?
Please do.
You want to? You can.
I'm very keen to see something.
We'll just get that lined up. And there we have it, your first ever live view
Okay.
of Jupiter, the king of the planets.
Oh, wow, yeah, there it is. I can see Jupiter looking bigger than it did with the naked eye, but not that much big, I've got to be honest with you, and some blobby stars or something next to it.
So that's good. Those stars are moons of Jupiter. We've got one moon orbiting around the Earth.
Yes.
Jupiter has got 63 moons,
Yes.
but you can see 4, and those 4 were discovered by Galileo back in 1610.
Good Lord.
Do you know the names of Jupiter's moons?
Well, I know our moon is called Alfie. I think...
I can see where this is going.
I think, is that Grumpy,
Grumpy, yes.
Sleepy, Dopey?
But this, the
60.
ones you can see are Io, Europa, Ganymede, and Callisto.
And Gallifrey.
And Gallifrey. That's in the other direction. How does that make you feel knowing, looking at something that Galileo saw 400 years ago?
Well, it's wondrous, of course. It's wondrous to see, but at the same time, I feel a little embarrassed that it's taken me so long, what with modern technology and how easy it is to actually get to do something that I wanted to do. I mean, Galileo did it on his own, presumably with a couple of plates and a tin can.
Not far off that.
Tell you what, I can't do how fast it's moving. It's almost left the range of my vision. It's incredible. So that's how fast we're spinning.
Yes, it is.
It's as we speak now, it's gone. Now it's
It's
gone.
gone now, is it?
It's gone. Isn't that incredible?
That's
Well, it's not
amazing.
incredible for you. You've done this
I've
before,
done
but
it
it's
before,
incredible
and
for
it's
me.
probably- Now, back again by the wonders of modern science.
Well,
You'll get
it's
back
moved,
down
of
again.
course,
No,
if
you've
you
got to get back
chase
down
it.
again, no.
If you chase the planet, you can keep seeing it. Seen it now. Where's another one?
Jonathan Ross, who has more telescope than sense, he'll be back for the second part of his lesson tomorrow when Mark tries to teach him how to navigate his way around the stars and the constellations. Now, we've been talking about Jupiter for a number of reasons. There's something special that's going to happen to it, but will we just have a look at this first? This is our solar system.
This is one of our high-tech pieces of machinery
It's very impressive.
that we've invested in. What's going to happen in the sky is something called a conjunction,
Right, now
which
this
is a rare
clearly,
thing.
if we ever get this conjunction of all 8 planets, you know, that the Mayans predicted that, like. That's
This is the geography. of
Flee
solar
the
system.
cities. If you ever see them lined up like this, you know, just there's going to be lava and screaming and hotels collapsing. I've seen the film. And it's,
This is going to happen in 2012. So.
oh, really? Oh, listen, I'm telling you, just store water now, right? That's all I'm
we've had
saying.
it.
Right, so they're all, let's move them. Because they're all...
You're going to just be clear about that.
Yeah.
It's not going to happen in
Yeah.
2012. The Mayans had no clue about anything at all. They were useless. Right.
Keep moving.
Let me
them
show
on.
you what I mean by conjunction. So let's get rid of all these planets. I should have
Right.
asked you what they were before I got
You
rid
should
of
have.
them.
I knew.
Let me just
I
say,
knew.
you
Well,
always get those
let's
two. What
let's
about
put
those
Jupiter
two?
back in, can we? Because
All
we
right.
need that. Yeah.
There's Jupiter.
Right.
No. There's Jupiter.
Yeah, lovely.
There's Uranus.
And you're the expert, right? So a conjunction.
A
'cause
conjunction
they
is
all,
as
they
seen.
all swoop around, obviously. They all swoop around in the same direction, but
They
at
all orbit
different
around the
speeds.
sun.
Yeah.
Yeah.
Okay.
I mean, Uranus takes 80. What is it? 85 years to go around the sun.
Really?
But at the moment, as viewed from Earth, then Uranus is very close in the sky to Jupiter. Now, Uranus is usually very hard to see. It's a long way away. It's
Yeah.
very faint in the sky. But on these rare occasions when this happens, when it moves close in the sky as seen from Earth, then it's interesting. It's a special time. And that's what's happening today at the moment. I mean, the next time that'll happen is what? We're down here, 2024.
Okay, Graham, we can see what it actually looks like. This is what you see when you see both Jupiter and Uranus in the same. There it is. There. I mean, it looks like there's a gap there, but that's through a telescope. I mean, like, would it appear even
Yeah.
closer to?
Yeah, you'll see it if you get a pair of binoculars or you've got a small telescope, then you'll see that. So it's a really wonderful opportunity, actually. to see
Very
Uranus.
rare for this kind of thing to happen. It is because all of them have a different orbital length. This is, you know, only the Earth goes around in 1 year and comes back to the same spot. Horoscopes, that's all nonsense. We're happy to say this now once and for all. That's all rubbish, right? Astrology, because the planets are in different places at different times.
In the interest of balance, because we're on the BBC, I should say that indeed Dara is right. Astrology is.
It's nonsense. It's absolute nonsense, right? Yeah.
But I should ask you some questions because we've been chatting about this in the pub last night.
Yeah.
So why? Because it's a good question. Why do all the planets orbit in the same direction around
Well,
the sun?
Okay, my pilot history of it, they all started as dust. The whole thing started as a big cloud of dust. And then it began to swirl and centre in the middle. And a certain amount of it squash, and became the sun. And other parts of it then accreted and
This is
became
true.
the
So it was a
planets.
spinning disk.
Yeah.
Why do they orbit in ellipses around the sun?
Because
With the sun at the focus.
of the force, because of gravity, because gravity is what we call a inverse square law, right? Which means that it's actually calculated by 1 over the distance of that squared, rather than just 1 over the distance.
Exactly right.
Yeah, and that makes it elliptical rather than. See, I'm just an idiot.
Why is gravity the inverse square law?
Why is gravity the inverse square? That really, we're almost out of time. And it's a pity because I could have gone for ages on this, right? Cloudy skies can cause havoc in the UK, which is why we've got Liz Bonin standing by for us now in Hawaii.
Thank you very much, Dara. I'm very impressed with your astronomical knowledge. I am in beautiful Hawaii, standing on the edge of the Kilauea volcano, the most active volcano in the world. But before we get into the business of volcanoes and planetary formation, let's take a look at why I've come all the way out here. So why did Stargazing Live choose to come to Hawaii? Well, Hawaii, especially the Big Island, is probably the best place on Earth to observe the night sky in all its glory. This is Mauna Kea, standing at just under 14,000 feet, one of the most prized astronomical sites on the planet. 13 telescopes from 11 countries watch the heavens through optical, infrared, radio and sub-millimeter wavelength telescopes. The setup here is incredible. I have never seen anything like it. And the combined light gathering power of all these telescopes is 60 times greater than that of the Hubble telescope that orbits our planet. And it's the exceptional climate and atmospheric conditions up here on Mauna Kea that produce images of our solar system and our galaxy and beyond that you just wouldn't get anywhere else on Earth.
Let's go surfing now, everybody's learning how. Come on a safari with me.
Hawaii attracts astronomers from all over the world. Gary Fujihara is NASA's representative on the island, but he loves Hawaii for more than just the stars. Gary, what do you think astronomy would look like if we didn't actually have Hawaii to study this science from?
Well, we'd be missing a good portion of what Mauna Kea Observatories has provided to astronomers to better understanding of, the Earth, where its place is within the solar system, and the solar system's place within the universe itself.
So when did Hawaii become such a mecca for astronomy?
When one of our last modern monarchs, King David Kalakaua, invited the British astronomers to come over in 1874 to view the Venus transit. That helped establish a baseline for the astronomical unit, or the distance between the Earth and the Sun.
Astronomy on Hawaii has a very long heritage, dating back to around 1,500 years ago, when the first Polynesians settled on these islands. Now, back then, they used their knowledge of the stars and their passage across the night sky to navigate across the seas, and they did a very good job of it. This knowledge is kept alive today by tribal elders like Kimo. He passes on this pioneering understanding of astronomy to his descendants.
Because they had to have some type of measurement, in distance, so what they had to do was plant it on the ground first.
Okay.
Rocks were placed around in a circle describing the type of clouds, the type of waves out there, and eventually from that scale model they were teaching also how to recognize the night skies. The stars are coming down to us now because of these observatories. We don't need to look too far and strain our eyes to find these stars anymore.
Hawaii may have changed over the years, but the spirit of Kimo's ancestors still lives on with today's explorers of the universe. And there you have it. Hawaii provides scientists with an incredible wealth of information and resources to help us better understand our planet and its place amongst the stars. And over the next 3 nights, I'll be showing you some of the best that this island has to offer.
Well, thanks, Liz. Keep enjoying the holiday as we are enjoying ours.
The
in Macclesfield.
Yes, let's see the man who's really bearing the brunt of the Macclesfield weather at the moment. Mark, have you seen anything yet?
Well, actually, the weather is holding relatively clear for us. We've got a bit of haze around, but Jupiter is by far the best object on view tonight. If you look due south, that's the brightest star you can see just to the right of due south. It's really that easy, but it's by far the best thing in the sky, and it's really stealing the show.
Now, growing up, most of my most evocative memories of space weren't done from observatories, they were taken from movies, because I'm a big science fiction geek. But we are going to kind of ruin them slightly for you there in a very nerdy way. A lot of what we see on screen just doesn't add up in the real world.
Whether you're a science fiction fan or not, you can't deny that the genre has given us some fantastically iconic cinematic moments. Lasers, teleportation, the use of warp speed, invading alien ships, and mainly big worms that live on comets. To help me decide what's science and what's art in all this, though, I've recruited Dr. Mara Kukula, Royal Observatory Greenwich's public astronomer, for a leisurely afternoon of Hollywood debunking.
Do you think people are going to hate us for ruining things?
I hope not. I love all of these films. I really enjoy watching them. And at the end of the day, I don't really care if they get the science right or wrong.
First up, let us boldly go where no man has, you know where I'm going here.
Star Trek? Where to begin? Do we go to the TV shows or the 900 movies?
Scotty, I need warp speed in 3 minutes or we're all dead.
There's a couple of general points that comes up over it. Well, warp speed for a start. Faster than light travel. That's a no-no.
Well, unfortunately, from what we know of physics at the moment, it does look like it's impossible to travel faster than the speed of light, which is a shame because really that's the only way to get to the other stars in our galaxy.
Are we bound, basically, by our own solar system, by the fact that we simply would take us too long to get anywhere else?
The fastest spaceship that we've built so far is called New Horizons, and that's heading to Pluto at the moment. It will take 10 years to get there.
And here's another classic. This is not your planet. You're diving onto it. Why are you taking off your helmet? How do you know there's air there? What are you breathing?
This is the kind of thing Star Trek always does well. You know? People trudging around with no masks on an alien planet.
So far, although we've discovered 500 or so planets around other stars, we haven't found any so far that have nice oxygen atmospheres that we could breathe in.
You hear that? None. We haven't found any, Spock. Why aren't you wheezing and dying right now? So what if the aliens come to us? I mean, that's a long shot anyway, but suspend your disbelief, because it's Independence Day.
The major problem is the bit where, like, Will Smith and Jeff Goldblum fly into the alien spaceship and plug by some weird USB port that works literally universally.
Brilliant.
Plug their laptop into the alien space computer and download a virus.
The virus is in.
So this is just an ordinary... How did you plug it into the alien computer? Where was the port?
All we can do now is pray.
It is
How do you
nice.
do that then, Mr. Science Man?
Yeah,
How do
well,
you do that?
obviously the aliens are compatible with Macs. I mean, I have problems getting my iPod to talk to my PC, but they clearly have a much better system than I do.
Okay, so Independence Day is generally quite silly, mind you. The bit where they blow up the White House is cool. But Han Solo wouldn't let us down, would he? We can rely on good old Star Wars, right?
Can't make the jump at light speed in this asteroid field.
Down, sweetheart, we're taking off.
Oh, is this Empire Strikes Back?
This is great. I mean, Han Solo swooping his way through the asteroid field. It's amazing. He's left, he's right. The rocks are going left, the Earth's going right.
It's like the Battle of Britain in space. But can you really fly like that?
This 1940s Red Baron business in space.
In space, there is no air, so you start moving in one direction, you keep moving in that direction until you apply another force to stop you or change your course. So flying through space is much more going like that and then like that, and you keep changing your direction yourself, but there's no air to bank against.
So they can't literally...
So they can't do that. Or that. So definitely can't do that.
Prepare to make the jump to light speed.
But if he can't bank left and right, how is he going to avoid the lasers?
But could you dodge the other ship's weapons?
Well, if the ships are firing lasers at you, it would be very difficult to dodge because you would only see the laser coming towards you when it actually hit you. Here on Earth, you can see a beam of light from the side, just like the projector beam up here.
Of course.
Because there's dust particles in the air, and those dust particles scatter the light out of the beam sideways, and so that's how you can see it. In space, if you fired a laser through space, there is no dust, no particles to scatter the light out the sides. So anyone watching a space battle from the side wouldn't see any lasers at all.
Oh, even Star Wars has let me down. And there we have it. Everything we've been taught in the movies is rubbish. Rubbish. But does it really matter?
It's just a kind of a geek thing, though.
I know, it's fun to pick holes, but they're great films.
Popcorn, please.
You see, I don't agree with something you said there. You don't need to travel faster than light to get anywhere in the universe. As you approach the speed of light, distances shrink.
Okay.
Something called Lorentz contraction. And so you'll need to go very close to the speed of light to be able to get anywhere very
However,
quickly.
but when you, by the same thing, your mass gets greater as you approach the speed of light.
This is
so
true.
you'd need more and more and more and more fuel.
That's
So
true.
that would stop us.
That's true, but in principle, if you went at the speed of light, if you had no mass, you would get everywhere instantly. So I'm just saying that your debunking needs to be debunked.
Oh, wow.
Very slightly.
Wow. You've done this job, though, haven't you? You've done science advisor to movies.
I did. I worked on a film called Sunshine, which Danny Boyle made, the premise of which was that the sun is dying and we're going to go and do something about it.
Yeah.
Which is nonsense. But putting that aside, one of the interesting things was Danny wanted it as correct as possible. So we thought of everything. But one thing that happens in the movie is the big spacecraft goes past and it makes a big sound. It goes, you know, there's no sound in space. Space is a vacuum. It was tried with no sound and it just looked cheap.
So
because
people
the
are just
spacecraft
used to seeing...
floated past.
Yeah.
People are used to seeing things. The other thing, famous thing, is weightlessness.
Yeah.
If you're weightless, you see people move slowly. They don't, of course, but it
There's
looks
no
wrong
reason,
if
yeah.
they move at normal speed. It looks like Laurel and Hardy. So you don't do it on the
So people, we're just trained to expect certain things.
to expect wrongness.
Now, I asked you, by the way, for loads of questions, and many, many questions have come in. Some huge issues and some tiny ones. Rory Smith asked, how far is 1 light year?
That's a good question. It is 10 million kilometres.
Okay, fine. That's a good one. Easy enough for me to remember. Lots of people have asked, what makes some things planets and other things stars?
That's a brilliant question. The answer is just mass or the amount of stuff in it. You see, if you get enough stuff into a planet, then the centre gets so hot that it starts to do something called nuclear fusion, which is what the sun does. So the sun takes hydrogen, which is the simplest atom, the simplest atomic nucleus, one proton, and it sticks it together to make helium, which is the next simplest. And in that process, energy gets released, and that's what a star does. It converts hydrogen into helium for a star, or the star like the sun does that. So, and you just need size to do that. You just need to compress the centre enough to make it hot enough to do that.
So Jupiter, for example, is made of the same stuff that the sun is made
Hydrogen
of.
and helium.
But it's just not big enough to collapse in on itself, to fall into it.
Yeah, so the gravity is not big enough to squash it sufficiently, to heat it up enough to initiate nuclear fusion, which would make it into a star. It needs to be about quite a lot bigger, actually, 50, 60 times bigger, or more massive, specifically, than it is now, to turn it into a star.
Okay, Malcolm Hill and Martin Liner both wanted to know, how come the sky is dark, given that there are so many stars out there?
That's a brilliant question. The initial asking of that question was called Olbers' paradox, and it was used to say, well, has the universe been around forever? And Olbers said, well, if it's been around forever, then every line of sight, if it were infinite, would end on a star. So the sky should be ablaze with stars. Now you might say, well, all right, well, what if there was dust around? Well, they worked out that the light from the stars would have heated up the dust if the universe had been around forever.
So what's stopping all the stars?
So, well, one thing is the universe isn't infinite. And it hasn't been around for an infinite amount of time. Well, it might be infinite in space, but it hasn't been around for an infinite amount of time.
So it's just we haven't got the star that hasn't all arrived to us yet.
That's right.
Okay,
So,
well, that's a very, very neat answer. These are all questions, presume, people have been asking for millennia.
These are questions that people have been asking for millennia, yes. These are very complicated questions. There's one that sounds quite simple, and it's puzzled civilizations in the past, and it seems very basic. What shape is our planet? Is it flat, or is it spherical? And I suppose you can see why there might have been some debate, because from here, the Earth certainly looks flat. Now, everybody knows that it's round, but how do you know? You know because someone told you. And I suppose if you really think that seeing is believing, then you would have had to wait until we left our planet, journeyed off into space, turned around and took a picture to see our beautiful spherical Earth in all its glory. This is the first ever photograph taken from space of the Earth, fully illuminated by the sun. Taken in 1972 by the Apollo 17 astronauts as they travelled to the moon, it became the most viewed image in history and was named the Blue Marble. This shape is echoed throughout the universe. Look at every star and every planet, and you'll see that the sphere is dominant. And it's all because of gravity, the same thing that keeps our feet firmly rooted to the floor. With gravity, the bigger the mass, the stronger the attraction. Now, I'm not very massive compared to a planet, and neither is this pier. So, the gravitational force that this rock feels is overwhelmingly dominated by the Earth. And so, when I drop it, it falls directly towards the centre of the Earth. And that's the reason that planets are the shape that they are. It's because gravity attracts everything towards the centre of a planet that they form as spheres. In the early days of the life of the solar system, our young sun was surrounded by lots of dust and rocks, but some pieces of rock were bigger than others, and that meant that they had slightly stronger gravity, so they attracted more and more smaller pieces to them, and they grew, and they became bigger and bigger and bigger.
And over tens of millions of years, these bodies grew so big that they eventually became planets.
Now, gravity doesn't have a preferred direction. You know, it doesn't care whether it pulls things in from over there, over here, over here, over here. So, what kind of shape will gravity tend to form? Well, it's not going to form an irregular shape like this, because gravity doesn't care about direction. It will form a shape that doesn't care about direction either. Now, the only shape in nature that looks the same from every direction is a sphere.
It's the most symmetrical shape in the universe, and that's why you see it everywhere. Now, it's not easy to mould solid rock into a sphere, but gravity gives planets a helping hand to form that perfect shape.
Now imagine this is one of those small pieces of rock falling towards the young, ever-growing Earth. Now when it hits the ground, it delivers energy to it. You hear some of that as sound, but some of it also goes into heat. Now imagine, over millions and millions of years as the Earth grows, how many millions and millions of pieces of rock smash into the Earth and make it grow. They deliver a huge amount of energy to the Earth.
And all that energy made the centre of our planet get so hot that it melted its solid core, making it even easier for the sphere to form. And incredibly, some of that heat is still escaping today, helping to fuel volcanoes across the Earth's surface. Gravity is the reason that our planet is spherical, but it doesn't always win out. Not everything in space is quite as perfect.
So spheres are fickle things. They only form over a certain size. Now, the rocks and pebbles on these beaches all have their own gravity, but it's far too weak to reshape the structure of the rocks into spheres. So, just like these beaches, the solar system is littered with odd-shaped rejects.
At 27 kilometres across, Mars's moon Phobos is so tiny it looks more like a potato than a planet. And covered in craters, the strangest of them all is Saturn's sponge-like moon Hyperion, which looks unlike anything else in the solar system. On average, moons must reach about 500 kilometres in size before they have enough mass for their gravity to shape them into a sphere.
The solar system is a world of spheres, but there are plenty of places out there that never quite made it. And it's quite a thought to think that if our Earth had been much smaller, then gravity would not have been strong enough to sculpt it into that beautiful, perfect blue marble that we see hanging against the blackness of space. Yeah, it's a beautiful bit of physics that, actually. So all planets are spherical, but they're not all the same.
No.
There are basically two kinds of planets in the solar system.
Now, these are the ones. Now, Jupiter, who's been our friend for the entire show so far.
Yeah.
Saturn further out. The two I keep mixing up the order of Uranus, Neptune.
The other way around.
Neptune, Uranus.
No, I was messing with you.
Right,
That is
sorry.
you.
Okay, fine.
So these are the outer planets.
Okay.
These are gas giants.
Now,
These
does that mean they got nothing in the middle? They just get denser and denser gas? Or?
No, they most likely do have solid cores, possibly metallic cores, but they're very small. They're essentially just huge atmospheres, balls of hydrogen and helium, which are the most abundant elements in the universe. So they're the outer planets in the solar system. And then the other kind of planet there is, are these four, the inner planets.
Okay, grand. We're down exactly in the same order as they appear. That is Mercury, obviously.
Yep.
That's us. And then Venus and Mars outside us. Yeah. And
I can't even say no, can I?
You can't say no. Of course you can't say no. I can recognise Earth. And they would have a much larger iron core.
Well, yeah, they have iron cores and they have a silicate, so rocky mantles, and these are the planets that are formed closest to the sun.
And
well, actually, it's not necessarily known that they form closest to the sun, but that's where they sit now.
Okay, grand. Well, why did the Earth turn out as it has? Liz is in the best place on the planet to explain.
Thank you very much, lovely Dara. Welcome back to Kilauea. All this volcanic activity is proof of the processes that created our own planet. So when scientists study planetary formation, this is an excellent place to come to. Now I'm joined by the lovely Dr. Sarah Fagan. Sarah, first of all, why do we have our rocky planets and then our gaseous planets further afield? What happened during the formation of the solar system?
The solar system formed from a vast cloud of gases and dust, and the sun formed first and it started to heat up. The location in the solar nebula where Earth formed was just too warm for volatile compounds such as water and methane to be, so they were driven out into the outer solar system to form the gaseous planets, and Earth and the other rocky planets formed from dust particles that were essentially rocky and metallic.
Excellent. And what does all this hot volcanic activity tell us about our rocky planets?
Volcanism is an expression of the interior heat of the planet. The Earth has a metallic core, a rocky mantle that's warm and convecting, and then the crust on which we live. And volcanism tells us about the heat that's being convected around inside the mantle.
It's a beautiful thing. Now we've got some fairly stunning images to look at. Beautifully held down by volcanic rock. There's a lot of it around here. And this is Kilauea. This is where we are. In fact, little sticker here, we're standing right here overlooking this incredible crater. And here's another image of a crater that looks fairly similar, but it's a little bit further afield, isn't it?
Yeah, this is the summit of Olympus Mons volcano on Mars.
And when we're talking about the scale here, this is not to scale. How much bigger is Olympus Mons than Kilauea?
Olympus Mons is really huge. The caldera here is about 80 times wider than the crater of Kilauea.
Okay, so if we look at our little graphics here.
We're zooming in here onto the Hawaiian island chain. The big island with Kilauea volcano comes up in the foreground.
There we are, yeah.
And as you can see now, superimposed on this is Olympus Mons volcano, which is really huge. It's about 20 times taller than Kilauea volcano. And the entire island chain of the state of Hawaii can fit within the diameter of the volcano.
It is humongous. So what happened to Mars for all this volcanic activity to stop, for Mars to become cold?
Mars is a much smaller planet than the Earth. It's a little over half the size of the Earth. And because it's so small, it loses its heat very efficiently to space. So although Mars was very volcanically active early on in its history, it cooled over time and volcanism waned.
Incredible. Now, other than our terrestrial planets, is there anything else out there that resembles the kind of volcanic activity we have on our terrestrial planets.
There is indeed one body in the solar system, and it's Io, which is one of the moons of Jupiter. And it's spectacularly volcanically active.
Look at that. It is literally littered with volcanoes. Now, how can something so small and so far away from our sun retain so much heat to create all that volcanism?
It's all to do with tidal interactions between the planet Jupiter, Io, and its neighbor moons, Callisto, Europa, and Ganymede. They flex Io, and it frictionally heats the interior of Io, which is expressed as volcanism in a whole variety of different forms.
Amazing.
But one of the features we see on Io that's very, very similar to the lava flow fields here on Kilauea are gigantic lava flow fields.
Excellent. And I was very lucky to get out to the lava flow fields of Kilauea, which are across the way from this crater towards the sea. In fact, the lava flows into the sea. And Professor John Sinton took me on a guided tour. Take a look at this. The crackling noise off it is amazing, and there's a fierce bit of heat off that. So tell me what's going on to create this kind of lava on the surface.
So this starts very deep in the earth. It travels thousands of kilometers in more or less a solid state. But as it gets shallow, it begins to melt. We have a large area under Hawaii where melt is being generated, but this breaks into smaller fingers that feed individual volcanoes like Kilauea.
And you get closer to that?
You
Whoa,
can get
you're
closer.
a brave man. Look at that. It's incredibly beautiful, isn't it?
Yeah. It doesn't look like it right here at this small flow, but it produces a lot of gases which protects us from the sun's rays, and I think there's no better example to see of how dynamic the planet is than to see lava flowing on the surface.
What an amazing place to visit. You get a real sense of the forces at work just from the sheer heat of the lava flow. Now, John is with me now. Thank you so much for taking me out there. We know a lot about the history of our planet through these volcanoes. Can we tell what's going to happen to planet Earth? Are we going to eventually cool down like Mars did and die?
Probably eventually, but not for a very long time. Volcanic activity is how we lose heat from the planet. If we continue to lose heat, eventually we will no longer be able to sustain volcanic activity.
What's the time scale here? How many years are we talking about?
A very long time. We don't really know, but probably more than 1 billion years.
Excellent. And Sarah, you know, I want to know about Earth-like planets. What are the chances of finding something like planet Earth out there in our solar system and beyond?
I think it's probably a case of when and not if. Astronomers are discovering more and more planets orbiting around stars outside of our own solar system. Given how many stars there are in the universe, it seems quite likely to me that we'll find a star that's quite like the Sun with an array of planets that are very similar to our own, and there will be a planet in that sweet spot that's warm enough and wet enough to be Earth-like.
And that's what we're holding out for. If anybody is ever enthusiastic about the universe, that's what we want to find out. Okay, back to you guys at Jodrell Bank. I'll see you in a bit.
Thanks, Liz. Well, Liz mentioned the possibly dead planet Mars there, although there has been some evidence recently there may be liquid water on that planet. It's fascinating. Might be dead, but it is certainly not ugly. And I've got to show you this picture because it's got to be one of my favourite pictures because it came yesterday from the surface of Mars, especially for us.
Is that from one of the rovers?
It's from the Opportunity rover, and NASA sent it through yesterday. And it looks Look at it. I mean, that's on the edge of an impact crater.
It doesn't look alien, which is a bit that strikes me. It just looks like a desert landscape. You can see a horizon there.
It's Earth-like, and as I said, some of the recent discoveries have been that potentially there's liquid water there, which might signal primitive life. So Mars is looking more interesting by the day. This is another superb picture. It was sent to us on the I think the 20th of December, so just before Christmas, from Saturnian orbit. And this is a picture of Saturn's moon Enceladus.
Okay, and what are those jets appearing under the...
This is the beautiful thing. I mean, Enceladus is a small moon. It's about the size of Britain. So it's a small place. But these are jets of water ice. So this moon has active volcanoes of ice on its surface, and they're spraying out into the air, into space so far. They're creating one of Saturn's rings, the E-ring. So this moon is active. It's probably because of the way it orbits around Saturn, and it's got these beautiful ice geysers.
And where else have we sent probes?
Well, this is the picture that it's actually a couple of years old now.
That's
but it's
not
a picture,
the moon now. That's my first guess. It was the moon.
This is Mercury, the innermost planet Mercury. It was sent by Mercury Messenger, a spacecraft on its way to Mercury. But the interesting thing about this is, I say on its way, it flew past, but it's not there yet. It's going to go into orbit around it in March this year. But I want to show you this because it shows you how difficult it is to fly to these places. This is a picture of the solar system. So here's the sun.
Right, that's us there, and that's where it's going from.
So Messenger began its journey.
It's got to get there. So you can't just go bing.
Well, you could, but it's not going to do that because it's getting to orbit. It wants to get into orbit around Mercury. And last time we went to Mercury, back in 1974, we did send a spacecraft direct there. It took about 3 months, and it just flew straight past. But this is the path that Mercury Messenger is taking. It was launched in 2004. The thing is, it's got to slow down. It can't just dive towards the sun because, you know, it's just, if you drop something onto the ground, it accelerates and accelerates. It would never get into orbit around Mercury because its gravity is weak. So it has to get into position, and it has to do
this crazy path isn't it being piloted? This is actually, it's set off from this path deliberately in order to just miss the planet.
It's called a slingshot technique. Yeah. So it's been past Earth a few times. It's been past Venus, I think, twice. And what it will eventually do is get into a position where it's just orbiting the sun at the same rate as Mercury.
And slingshotting is when you take some of the energy essentially from the planet. You get closer. So not that you're going to crash into it or orbit around it, but just it's the way it's explained to me. Might be silly now, but it is a merry-go-round. Like say there was a merry-go-round and you cycle past a merry-go-round, and a man on the merry-go-round reached out, grabbed you, pulled you sideways, and let you go. That is basically the principle of it.
I hope that wasn't your physics teacher. They should be sacked.
Oh, really? Okay. But the gist of it is right.
Joking aside, that's true. Yeah, it's essentially taking energy from the planet by passing close to it. And that's how you fly those vast
And you can use it to speed up, or in that case, to slow it down so it meets up.
Yeah.
It's astonishing.
Beautiful.
Now, early on, we asked you to send in your best images of things you'd captured in the night sky. Here's a quick look at some of the best ones you've sent in to us already. Let's have a look at these.
We want pictures.
Okay, that is what's appearing above Swindon at the moment. Swindon are fearing an apocalypse if that's what's above their head.
Get outside!
Yeah.
I assume he's got a wonderful telescope.
For that. Look at that, it's an astonishing picture. This from Bradford, Rock with the lunar surface. Let's have a look at another one.
And that's beautiful. That's the Pleiades.
Fantastic.
Which is a star cluster.
Keep them coming in. If you're not entirely sure how to take a great photograph of the night sky, here's Mark with a few handy hints.
You might have thought taking photos of the night sky would be difficult, but thanks to advances in technology, it's never been easier to capture images of the stars. Taking pictures of space is really good fun,
And the great thing is you don't need lots of expensive kit, just a basic digital camera. You don't even need to go out into the countryside. In fact, you can get some fantastic results from the comfort of your own back garden. There's one important consideration when photographing the night sky, and that's that the stars are faint. So you need a camera that's capable of taking long exposures, and you need something to keep it still. So I've got a DSLR camera, I've got a tripod, and a piece of card. Now we need to do 4 simple things to get the camera set up to take the picture. We need to set it to the manual mode. We then need to set the aperture so the aperture is nice and wide. We need to set the exposure to about 30 seconds. And then finally set the ISO setting to about 800. And once that's done, the camera is ready to take a photograph. But unfortunately, it's cloudy here tonight, so I'll just have to show you how you take the pictures and let you go off and try it yourselves. Now, you've got to find the constellation that you want to take the photograph of. So we get the camera lined up first. So we put the card in front of the camera to make sure any vibrations that you give on the camera through taking the picture and touching the camera are not seen, and then push the shutter and then take the card away for 30 seconds, and it's as simple as that. You've been sending us in fantastic images using the DSLR camera technique. This gorgeous image of the Hale-Bopp comet taken by Jamie Cooper includes a tree line to give a sense of scale. And this stunning photo of the Northern Lights in Scotland by Stuart Watts is a great example of how long exposure can capture constellations. Once you've taken some photographs of constellations, the next thing you might want to try is taking pictures of planets through a telescope. Now, some surprisingly impressive results can be had by using a simple compact camera, placing it against the eyepiece of a telescope, take a picture. You can get some amazing images. I love this wonderful photo by Andrew Richens, taken with a compact camera held to a telescope. You can see the moon in the foreground and Saturn and its rings in the distance. Here's an amazing shot of the moon taken using the same method. You can almost feel its surface texture. And if you go a step further and connect your DSLR camera to your telescope using an adapter, you can open up a world of unbelievable beauty. These images were taken by amateur astronomer Dave Moulton. This is the Great Nebula in the constellation of Orion. This photo has captured not only the amazing jellyfish nebula, but also its star, Eta Geminorum. And this is our nearest galactic neighbour, the majestic Andromeda Galaxy. An even better way of taking images of planets is to use a webcam. Now you need a special type of webcam, and I've got one here that you can unscrew the lens, and I replace it with a special adapter which you can buy from astronomical suppliers, and make sure the object is still in the centre of the eyepiece of the telescope. Take out the eyepiece, pop the webcam in its place, and then very simply with the capture software we take a 20 or 30 second video. I filmed this image of Saturn a few nights ago. Back inside in the warm now, we need to take that video that we took off the webcam and load it onto the computer and turn it into a picture. So you search for webcam stacking on the internet. We can find a piece of free software which will allow us to load that video into the computer. and then we simply use the automatic function of align and stack, and that basically takes all the individual frames and overlaps them perfectly and effectively cancels out the turbulent effect of the atmosphere. And there it is, our final picture of the planet Saturn. So with a bit of practice, you can create some spectacular webcam stills. And as you can see from these inspirational images, all photographed by amateurs, with a little effort, the wonders of the night sky can be yours for the taking. So taking images of the night sky is really easy, so I want you all to get out there and give it a try. Obviously not until after we finish the show. Now, if you're lucky like us and we've got some clear skies, then there's plenty of things to see in the night sky. We've already talked about Jupiter and it looks stunning, so please get out there and take a look. We've got a live image coming straight from this telescope now, and you can see 3 of the Galilean satellites, and it's easy to find out to the southwest. Now, all the really exciting stuff is taking place after midnight. If you're out of bed by 7 o'clock in the morning, then due south you can see Saturn and Venus to the lower left. Now, the really important things we want you to concentrate on overnight are the quadrantid meteor shower, which peaks around 4 to 6 a.m. in the morning, and that looks stunning. Just take a look at this video to give you an idea of the sort of things we're looking at. But perhaps more interesting than that is the solar eclipse. A partial solar eclipse of the sun will happen between 8 and 9:30 in the morning, depending on where you are in the UK. Now, if you want to know how to safely look at the sun, and you can very easily go blind looking at the sun incorrectly, take a look at the details we've put on our website, and that will show you how you can safely observe a stunning solar eclipse. So the message is, make sure you read that before you go out to observe the eclipse first thing in the morning.
Yeah, we can't really stress that enough. There is a genuine danger of blindness if you spend too long looking at the sun, and in particular if you look at the sun through any optical instrument. You're staring at a nuclear reactor, basically, so don't do that.
Gotta say that those pictures, remember what do you need that for?
Yeah, I know.
You just need him.
Yeah,
just install him here and take that away.
We got it in his garden. On our website there's info on how to view the sun tomorrow morning, bbc.co.uk/stargazing. However, this being Britain, we are totally dependent on the weather, so we're here to tell us which parts of Britain are in line for the best viewing conditions tonight. Here's Laura Tobin from the BBC Weather Centre.
Hello there and good evening to you. I've tried my very hardest to create some clear skies across the UK, and we have got some. They're slowly starting to develop and clearing their way southwards. This big swathe of clear skies from Lincolnshire through the Midlands, just holding on to Manchester, pushing through East Wales and down towards the southwest of England. And with the clear skies from tonight and into tomorrow, perfect conditions for viewing those meteors. Now, as we head from midnight onwards, our clear skies slip their way southwards, heading towards Lincolnshire, towards Norfolk, and through the Midlands as well. And it's for these areas, say from midnight 45 and for 4:15, where you could see Saturn and Venus, thanks to those clear skies. Through towards dawn, I think it's the southernmost coast of England, through Dorset towards Cornwall, and then later on we will see clear skies across eastern England and the eastern areas of Scotland as well. There's where they're seeing the best conditions for the clear skies to see the partial eclipse. I'm working on the rest of the week, and I will try to create more clear skies later on.
Thanks, Laura. It's looking pretty good, actually, I think. Get outside after the show's finished. Anyway, over to the beautiful, clear blue skies of the Pacific.